Hello everyone. Welcome to Geeks for Geeks Practice. Today we are going to discuss a question that was recently asked in an interview at Microsoft. So before going into it, let me first confirm that if I am audible or not. So if you can just write a yes if I am audible and visible to you properly. Thank you Dhananjay for confirming that I am audible. So let's begin our today's lecture. So as you can see on the screen, we have the question that given a string, we need to find longest palindromic subsequence. All right, let's go to the practice portal of Geeks for Geeks and read this question in detail. After that, we'll come here and see how we can develop its logic. Yeah, so given a string, we need to find the longest palindromic subsequence. So let's see what is our task. This inputs and output I'll explain on the whiteboard. Our task is that we don't need to read input or print anything. We just need to complete a function longest palin subseq, which takes the string s as input and returns an integer, and that integer denotes the length of the longest palindromic subsequence of the given string. So let's go to the whiteboard and let's try to understand the question in detail. What are the minute things which we need to consider while developing the solution? All right, so given input, let's say we take this input BBA, BCB, CAB, and the output is 7. Now, how come the output is 7? Before going into all of this, let's try to understand the meaning of palindrome, meaning of subsequence, and obviously longest means that you need to take the maximum length, right? So what is palindrome? Any word, if it is read backwards and forward, like from left to right or right to left, let's say I take a word A, B, A. So if I read it from this side, sorry, if I read it from left to right, and if I read it from right to left, it is same. For example, if I read it from right to left, it is A, B, A, and if I read from left to right, it is again A, B, and A. So such words are called palindromes. I hope this is clear to you. Let's come to the term subsequence. This is interesting. Subsequence means, yeah, yeah. So subsequence means, let's say you are given a word. Let's take this word. What you can do is you can consider its characters, like if it is present or not present. You have two choices in front of you. Let me explain. Let's take this word BBA, BC, BCAB. BBA, BC, BCAB. Right. So what you can do at each position, you have two choices. Let's say I take this position. Okay. So in subsequence, you can either include this or exclude this. Similarly, you can do for rest of them. But what is the catch? Don't you think this is similar to subset? There's a difference. In subsequence, ordering matters. What I mean to say is A, B, or let's say AC is a subsequence. What I have done, I have taken this part and I have removed this B, but I have maintained the order. Okay. So AC is a subsequence. Now let me take one more example. Let's take AXYT. In over here, I will show you the difference between subsequence and a subset. Okay. So over here, your subset could be YX. Okay. This could be your subset. But YX can never be a subsequence because X comes before Y in my original string. So we have two conditions: whether we can take that particular character or whether we can remove it. First one, and the next one is ordering should be maintained. Like you cannot rearrange the letters, okay, after taking it or removing it. So I hope the concept of subsequence is clear to you. If you have any doubts, you can let me know in the comment section. So let me erase this part. Yeah. Now let's try to develop the logic for this question. How can we proceed? See, the very first approach that comes to my mind is that I can take out all the possible subsequences of my given string, check which one of them are palindromes, or let me write it down. Let me take out all the subsequences, okay? After that, the next filter will be which one of them are palindromes, okay? And if I got the palindrome subsequences, I will take the longest one, right? Now, let me explain how we are getting this output 7. Then I think when I go with the logic, that will make more sense to you. So see over here what is happening. If you consider this portion of subsequence B, A, B, C, okay, and after that this B, you are excluding this C, okay, and you are taking this A and this B. So what it's becoming B, A, B, C, B, A, B. So what I have done, I have considered from here, that is this second character B, A, B, C, B, A, B. I have removed that C. And that's what you see in the output also. B, A, B, C, B, A, B. So if you read it like from right to left also, it will come out as the same string. So it is B, A, B, C, B, A, B. So this is a palindrome, as well as in this particular string, this is the longest palindrome. Okay. So what is its length? 1, 2, 3, 4, 5, 6, 7. Hence your output is 7. All right. So I hope the explanation of the given sample input and output is clear to you. Now let's come to this logic. All right. So figuring out how many subsequences are there. First task. All right. So if you look at this particular string, let me clear this part a bit. If you look at this particular string, okay, how many characters do I have in total? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? I have 9 characters. Now, at each position, I have two choices. Either I can take it or I cannot take it. Okay, so if I have, let's say, sorry, my bad. Yeah, if I have, let's say, let's take smaller input. If I have, let's say, 4 positions, I have two choices at each position, right? So can I say 2 to the power n will be the total number of subsequences, where n is the length of my string. So fine, at the very first task, I know that I will get 2 to the power n subsequences. Now, for each of them, I am checking if it's a palindrome or not. Okay. After that, I am again checking which one is the longest palindrome. So the time complexity is anyways exponential over here itself. Okay, so you cannot like, even if you do these things optimally, still it's going in the order of 2 to the power n, right? So what we are going to do, we will be doing same thing but in a smarter way. Like I will be somehow writing a good way to check palindrome, and I will be not going through all the 2 to the power n solution, okay, or 2 to the power n subsequences. I'm sorry. We'll be not going through all the 2 to the power n subsequences. We will smartly try to find out a way where we can reach to our answer, and along with that, we could reduce this number to some optimal range. Okay. So in order to explain it, let me clear this portion of the screen. Like how can we do this? Let's see. So we have the original string as BB, AB, CB, BB, AB, CB, CAB, right? AB, CB, CAB. Let me write the same string from right to left. So what it's becoming? B, A, C, B, C, B, A, B, B, right? B, A, C, B, C, B, A, B, 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 A, C, B, C, B, A, B. All right. So I have written the same string. This is my string 1, which is given to me as input, and this is my string 2. What I have done, I have written the same string from right to left in S2, right? Now, if it is a palindrome, okay, or if it is required that we need to find out a palindrome, can I say that the common subsequences between these two strings will give me palindromes? Later on, I'll talk about the longest. But can I say that if I take common subsequences in each of these strings, I'll get a palindrome? For example, if you observe over here, we have, just a second, we have B, A, B, C, B, A, B, right? Now, if you look over here, we have B, A, B, C, B, A, B, right? So there you go. Like we have got already the explained answer in our new string S2. Like this subsequence is also lying over here. So let me just cross verify again. If you see over here, what we have done, we have excluded this C and taken from here to here, right? B A B A B C B A B. Okay. And over here, what we have done, we have gone till this part, starting from here. So B A, we have excluded this. So B A B C B A B, right? All right. So, and this is a palindrome as well, because if you read it either from left to right or right to left, both of them are same, right? So now we have achieved a position where in order to find palindromes, I have a smarter way. What is that? I will reverse my input string and I will find out the common subsequences between them. So my task now boils down to how to find out the common subsequence, right? Like the question has changed. The question was earlier we had only one string given to me and I was asked to find the longest palindromic subsequence. Now the question becomes, I have two strings with me. The very first string is the original string. The second string is the reverse of the original string, right? And what I need to do, I need to find out the common subsequence between them, and that should be longest also. So let's go to the part of finding the longest common subsequence between the given two strings. Okay. If you have any doubts in the explanation till now, okay, or if you find difficult at anywhere, like till now, whatever the lecture has went, you can obviously comment it and let me know. Okay, let's proceed. So what we'll do, we'll take a small example and we'll try to modify our logic on a small example, because taking such a long example every time, first of all, it needs a lot of calls, because there will be 2 to the power n subsequences. So that would be not feasible over here to draw on board. So what I'll do, I'll take a smaller input and I'll explain it to you over there. Okay. So let me take a fresh board for that. All right. So we are going to use this as our input to explain our logic further. Okay. So as we discussed, we have a, x, y, t as one string. And the next string, what will be the next string? Reverse of this. So it will become t, y, x, a. Right. We need to find out the longest common subsequences of these two strings now, right? So let's have a look at it how we can do. So what logic I am proposing is, I will start looking from extreme right of both the strings, okay? And I'll have two choices over there, whether these two are equal or unequal. I'm sorry, whether these two are equal or unequal. So over here, t is not equal to a, right? So what we can do is, if t is not equal to a, we have two choices. We can later on search, just a second, yeah, we can exclude the last element of any one of them. Don't worry, I'll explain it in detail. Let me write it. See, over here I have excluded this a, okay, in this call, because see, when I have two strings, if the last character of both of them are not matching, there is a possibility that this last character could match with the second last character of this string, right? And similarly, if I take the last character of this string, there is a possibility that this small a could match with second last character of this string. I see that over here, those are not possible, but I'm saying in a general scenario. Okay. So let's proceed. So the another call could be AXY, comma, TYXA. So what I have done, I've compared my last two characters of both the strings. I saw that both of them are not same. So what I have done, I have, let's say the length of this string is m, okay, and it's n over here. Although if it is a reverse of the same string, so m is equal to n in this question. But just to differentiate, I will be writing down more function calls. So just to differentiate between them, I have taken m and n. Okay. In this case, m is equals to n, I repeat. Okay. So what is happening over here? We are calling with m length, comma, n minus 1, right? And over here we are calling with m minus 1, comma, n, right? This is what I see. Because this is one possible scenario, right? That we'll call on both of them and we'll see like what could be the answer from here and what is the answer from here. And at the end, we will take max of both of them. Okay. Max of both of them will be taken. All right, we missed out one scenario. What if these two are equal? Let's say we take a situation where the first string is A, B, C, suppose. Okay. Let's take ABA, and the second string is, as is a palindrome, the second string will also become ABA. So over here, I see that last two characters are same, right? They are A and A. So what I can do in that case is, I can straight away take one as my answer, that at least one length subsequence I'll have, and I'll call in, sorry, and in the next iteration, I'll call on only these part of the strings. So if I write it down, how this becomes is, okay, let me zoom this out a bit. If you have S1 and S2, let's say there is of length m, there is of length n, and as indexing goes from 0, so for m, the last character will be at m minus 1. Similarly for n, the last character will be at n minus 1, right, of the string. So if S1 m minus 1 equals to S2 n minus 1, then what I am doing, I am returning 1 plus, because I know that I have already got these two characters equal, so I can further call, let's say I name the function as solve, I can further call with the length S1, S2 two strings, and length m minus 1, comma, length m minus 1, comma, n minus 1, right? I can further call on this. Else is the scenario where these two are not equal. So I'll write the else part over here. So what we are doing in else part, we are taking maximum of solve m comma n minus 1. Sorry, the first two arguments are s1 and s2. So we'll write accordingly. This is s1, s2 with the length m comma n minus 1. Max of this as well as solve s1, s2, m minus 1 comma n, right? So this becomes our else part, right? This becomes our else part and we will return it. So how is this helping us? Is this helping us reducing our time complexity from 2 to the power n, like it was in the order of 2 to the power n earlier? Yeah. Is it helping us? As of now, I don't think so, because still we are going through all the places, okay, and we are taking full string consideration. What I mean to say is, see, even if you are going and checking the last two strings, if they are equal, you are calling one less than length of the both the strings, right? And if they are not equal, you are calling on m comma n minus 1 and m minus 1 comma n. So still you are exploring all the possible subsequences, right? So this is the place where we will look at recursion tree. Okay, this, what is this? This is a recursion. If you carefully observe, all these things will be written inside the same solve function. We'll see the base case also in a moment. We'll come to all of that. But before that, I just wanted to give you a feel that we have still not improved on 2 to the power n. We have just improvised on how smartly we can take out palindromes. Okay, so taking out palindrome was just reversing the given string, and now we'll have a look how we can make the 2 to the power n smaller. Okay, so for that, let me clear this screen. Okay, let me clear this screen, and let's have a look at base case recursive calls. There will be nothing new except the base case. Recursive calls you have already seen. I'll just write them in an organized way now. So this is how my solve function will look like. I have solve. Okay. This is just a pseudocode. Okay. So this will not get compiled. I'm just trying to give you an idea how the code will look like, because I'm not specific to any language over here. So let's say my strings are S1 and S2, and the length given to me is M and N. So if M or N, any one of them is 0, can I say that my final answer will be 0? Because you don't have a substring at all. Sorry, because you don't have any string, any character present in the string. Let's say if this M is 0, what does that mean? That means S1 is empty. If N is 0, it means S2 is empty. So this will become my base condition. If M equals to 0, or N equals to 0, return 0, because no subsequence is possible. This will become true when either M is 0 or N is 0, or when both of them are 0, right? So this will be my base case. Now what I have told just now, if S1 M minus 1 equals S2 N minus 1. Okay, I'm just checking last character of both of them. If I write, this becomes TYXA. So I'm checking this T and this A. If they are equal, what I need to do? I need to return one plus solve S1, S2, M minus 1, comma N minus 1. Because I'm already done with the last two characters and I have found out to be same, then we are returning this. Like I'm decreasing both the lengths by 1. So this is not in this case because we have T and A which are not equal. So I'll come to this else part. Now see, we have a return already over here. So writing this else will not help us in the sense, just for the sake of clarity I'm writing. But as you have return over here, so it will function will automatically return. Like this else is not required. You can, without this else also, you can write your, just a second. Yeah, without this else also, you can write your next condition, because your function will return over here itself, so it will not come down. Okay, so let's do this. So now my next scenario is, if, or for the sake of standardness, let's write else. Else is the case when these two are not equal, right? So what you're going to do over here, you need to return max of solve S1, S2, M comma n minus 1. Okay, the very first call. Second call will be solve of S1, S2, M minus 1 comma n. Okay, and that's it. That's it. Now, for this recursive solution, let's draw the tree and try to understand how we can reduce 2 to the power n subsequence calls. Okay, so let me just zoom this out a bit. Yeah. Let's take this string axyt. So what will be its reverse tyxa, right? So what we can do is we can start checking. Initially, neither of them is 0, like m is 4, n is also 4. So what we do, we come over here and we check whether last two characters, this t and a, are equal. No, they are not. So I'll be calling on m comma n minus 1, that is axyt tyx. And over here, there will be one more call of axy and tyxa. So this is m comma n minus 1 and this is m minus 1 comma n, right? Let's proceed further. I'll show a place in this recursive tree where your smaller subproblem will occur at more than one place. Like we will be calculating smaller subproblems again and again, same smaller subproblems. So that is the place where we are going to optimize. So let's have a look at this. So now again this will become m comma n minus 1. So this will be m comma ty, okay, and this will be m minus 1 comma n. So this will be ayx. This is tyx. Sorry, axy and tyx. Similarly, this will be m comma n minus 1 and so on. So if you carefully observe, we have already found out these two subproblems are same. Sorry, these two subproblems are same, right? And we are calculating it two times again and again. Like I've just shown you some part of the recursive tree. There will be more instances. I mean, there can be more instances of this type. Okay. If you carefully observe what I did from the beginning, this was my of length m. This was my n. This is becoming m. This is becoming n minus 1. Right. I'm going with this calls. And why I'm going every time with this calls? Because I'm checking the last characters are not same. That's the reason I'm going with this part of my code. I'm going with this part of my code, right? T is not equal to a, over here T is not equal to x, right? Similarly, that after that we have again done m comma n minus 1, okay? See how this n minus 1 is working or m minus 1 is working. Whatever is your last string, you are taking that particular length, okay, at that point of time. Like over here I have 3, hence I have made 1 decremented, so it becomes 2, right? So I hope this is clear to you, like we are getting similar sub problems. So now we are going to see how we can optimize on this. Like I don't want to calculate my smaller sub problems again and again. What I can do is I can store the result of these smaller sub problems while going through my recursive approach, and that concept is known as memoization. So let's see how we can do that. So let me erase this portion of the screen because I'll need some space. Yeah, I will suggest you that you try on yourself on small piece of string, let's say this string, and realize that we are getting smaller sub problems again and again, and we could store that answer. All right. So let's do it. So over here, m and n, right? We have the length m and n of strings s1 and s2. Okay. What I'll do is I know that these are changing, right? M and n is changing. when in my recursive calls, right? The lengths are changing. So I'll take a 2D DP array, okay, of size m plus 1 and n plus 1. Now you might ask why plus 1? Because indexing is always one less than the actual location. What I mean to say is, let's say this is your string, right? AXYT. The indexing is 0, 1, 2, 3, right? Now, how will this m plus 1 look like? Like if I want to refer to the third position, I cannot take a size of 3 because it will be indexing will be only till 2. That's the reason I'm taking one greater than that. So if I want the answer for third position, I can have a look at over here. Exactly the same thing is not going to happen. I'm just giving you a feel why we do plus 1. Plus 1 is done mostly in memoization solutions because you don't want to mess up the code with zero indexing. You want to keep it in tally, the exact location and your index number. Okay. We'll see how we are going to do it over here. Just for the sake of explanation, I have taken it, but exactly in this question, it's not going to happen like that. I'll explain it to you. What do we mean by m plus 1 and n plus 1? Why we have taken 2D array? I'll explain in a moment. Okay. So let me create some more space. Okay. So over here, n is 4, right? M is also 4, n is also 4. So what I am going to do, I am going to take a 5 cross 5 DP array. So this looks like 0, 1, 2, 3, 4. This also looks like 0, 1, 2, 3, 4. Now what does each of this cell denotes? See, 0, 1, 2, 3, 4 is nothing but, just a second. 0, 1, 2, 3, 4 is nothing but how you are going to place your characters. Okay. So this will, let's say this is my M. Okay. And this is my N. So TYXA will be placed like this. Okay. And over here, similarly, AXTY, AXYT will be placed like this. Okay. So this means that if I consider this particular cell, this means I'm trying to find out the longest common subsequence of TYX and AX. Okay, at this place. Now, this is the way like we will be going to store our smaller subproblem answers and eventually return this value, which is the longest common subsequence of TYXA and AXYT, right? Now, one thing to focus over here is that even though we have used this DP array, we cannot leave it blank initially. Why? Because then how will you keep a track? How will you keep a track of which smaller subproblems have already got calculated and which are left? What I mean to say is you should have some default initialization for this particular DP array. So what I'm going to do, I'm going to initialize it with -1. Okay. I'm going to initialize all the positions with -1, okay, of this particular DP array. All right. So now, how will this -1 help to me? What changes I need to do in the code? Let's have a look at it. Over here, we are going to pass a DP array. Now, I have seen many programmers taking this DP array globally, so it's up to you. So you can pass or you can take it globally also. After the base case, you will check whether DP if it is not equal to -1. What does it means? If it is not equal to -1, then I already have my answer. Already have my answer in the sense, if this is not -1, then this is some non-zero value, right? That means we already have our longest common subsequence till that point of time. So we'll straight away return from there. We'll return the value of DPMN, right? If this is not the case, then only we are going to proceed forward. I'm sorry, today this board is like rotating a lot. So then only we are going to proceed forward. Otherwise, see our program ends over here itself. Okay. And yeah, you can remove this else. Okay. You can only write this. because anyways you're returning from here. Okay, so yeah. Now you are returning your some solution from here and some part of the solution from here depending on this check, right? So over here also, while you are calculating, while you get your answer for this, before returning, what you need to do, you need to store it in dp mn, and that mn could be some other value which is at that point of time in the recursive call. Similarly, before returning over here, you again need to store it in dpmn. Okay, and what you can do, like if you, I'll just go to the code after this, but to give you an idea over here, you could either return dpmn after all the calls, okay, or you could return dpmn like after you store it. Why we need to store every time? Because see, the first time we have our solution, we don't want to recompute it again. So that's the reason at the very top I have kept a check. If it is not equals to -1, that means we have already computed, right? We have already computed the result. So let's go and have a look at the code now. Yeah, so this is your code. Okay. This is your code. We were asked, just a second. Yeah. Yeah, we were asked to calculate. Let me change the color. Sorry, we were asked to complete this function. So what I have done over here is I have taken a new string reverse str. I have iterated from the last index of my given string till 0th index, and I have appended all the characters in my reverse string. So this will help me create reverse of the given input string, and finally we have called reverse str and s, all right, and that will return the final answer, because we have seen in the logic, right, we were doing longest common subsequence on reverse str and s. So let's go up and let's try to figure out what's happening. Just a second. Yeah, so over here we have this lcs function. Over here we have this lcs function where we are taking string s1 and s2. This is your, let's say, given string, and this is your reverse string. Like if you observe, that's what was there. Okay, the first one is the reverse string, next is the given string, no problem. So this is your reverse string and this is your given string. All right, so what you have done, you have taken our dp array initially. You have initially taken a dp array of length 1 greater than s1 dot length. Similarly, the column is length 1 greater than the length of s2. See, I have explained all these things in very detail while going through the logic. Okay, I'm just trying to create an analogy. After that, I have initialized them with -1, called LCS util function. I have passed dp array. You might take this globally also. So I have passed both the lengths. Okay, let's go up now. Yeah. So this is the main function which is doing all the things for us. So initially we are checking if m is equals to 0, n equals to 0, straight away return. After that, I am checking here itself if the value of dpmn is not equal to -1. That means I have already computed my answer. So return from there itself. Why to go further? After that, I have done s1 dot char at n minus 1, s2 dot char at n minus 1. So if you remember our input, this is, let's say, one string, and if I take this becomes tyxa. So this is coming as s1, this is coming as x2, right? Now this is checking a is equals to t or not. So it's not, so it will come to this part of the code. And again, as I explained, you are calling on m comma n minus 1 and m minus 1 comma n, taking its max, and it again goes up and checks if it is already there. Otherwise, it again comes to line number 36 and tries to compare the last elements of the new s1 and s2 that is passed from here, right? Why new s1 and s2? Because you have decremented one length of s2 over here. Similarly, you have decremented one length of s1 over here. So the corresponding characters at m minus 1 and n minus 1 will change for the separate calls. And if we get same string more than one amount of time, then at the very first moment, it will get stored in this dpmn. Okay. when you calculate it, you return this dpmn. That's the reason it's getting stored. Like this is how recursion works. And the next moment you encounter the same sub problem, you this line will help you. How come this is getting reduced from 2 to the power n to some lesser complexity? So what you can do for that is you can take this example, okay, or you can take the bigger example which I showed in the beginning of our lecture, and you can draw the recursive tree. You will realize that this is playing a key role. You don't have to go through all the calls. You can straight away return some calls from here. So you are not going to all the 2 to the power n calculations again and again. That will come out in the order of mn, okay, m multiplied with n. Over here, although m and n is same because we have reversed the same string. Now I will suggest you that you dry run it yourself on, let's say, this input and try to figure out how this is exactly storing. Although I have showed you to some extent when I was going through the logic, but like if you have any doubts, you can let me know in the comment section. Okay, I'll surely answer from there, because I have explained it multiple times how we are going from storing the dpmn value and again reusing it, right? So I hope the code is clear to you, like each and every part of the code. Or if you have any doubts, you can ask me right now. So let's try to compile this and execute, okay, run it. So let me clear the canvas. Yeah, just a second. So if I compile it, okay, this is the same input string which was given to us in the sample input. So the output is 7. Let's try to submit it. All right, so this is giving the correct answer, which is running in 0.40 seconds. So I hope this code was clear to you today. See, these kind of questions, when asked in interviews, you should first of all try to relate with what you already know. What I mean to say is, when I read this question for the first time, longest palindromic subsequence, first thing which came in my mind that whether it will be a variation of a problem which is a very standard problem, longest common subsequence. Can I do something from there? So in longest common subsequence, two strings are given to me, right? Now over here I have only one string. So I try to develop some relation. Then I finally figured it out that okay, if I take reverse of the given string, then after that, if I do the longest common subsequence between the two strings, I am ensuring that it is a palindrome because I have reversed it. And if we get a common subsequence that itself says that reading it from left to right or right to left, I am getting a common subsequence. So it will be a palindrome, right? Because you have reversed the same string. So palindrome condition was ensured over there. After that, I tried to have a look, how can I optimize it? Can I reduce those number of calls? So we did that with the help of memoization. And trust me, these kind of problems, if you look at it from a blank state of mind, like longest palindromic subsequence is given to you. Now in interviews, you might not be able to reach to optimal solution. Like you can always write the brute force solution of taking out all the subsequence and then checking with a separate palindrome function, it's a palindrome or not. After that, separate length function, or if you can, or you can also use inbuilt length functions, right, in C++ and Java. So you can reach to brute force solutions, but optimizing it, you need to be smart enough with recursion. You need to be smart enough how to do memoization. Like once you have written the recursive solution, and even after memoizing, you should be able to explain your interviewer that how you have reduced the time complexity. For that, you need to draw the recursive tree and show it to them that this is how I have removed these many calls because my answer were already stored. Okay. So I hope this question was clear to you. If you have any doubts, you can ask in the comment section right now. All right. As I see that we don't have any questions today. So that's it for today's lesson. We'll come up with more such good questions that are asked in product based companies in their interviews in our coming week, as well as on every day of this week between 3 to 4 p.m. So thank you for joining Geeks for Geeks practice.